Hey guys, today we are going to start putting together all of the things that we've learned in this past unit, and we're going to start solving trig equations. So we've been doing this throughout the old parts of the unit where we're looking and we're trying to condense things that look like this so we could go on our formula chart and realize that this is a sum and difference property or that this is a double angle property, and then I can go through and make it so it just says the cosine of something minus something, and then I can solve that equation out. What we're going to look at today are ones that aren't basic trig identities and that we kind of have to manipulate down until I get it till it says something of just one trig function equals some number. So let's get started. The first one we're going to deal with is 4 cosine squared theta equals 3, where theta is an element of all real number degrees. And what this means is that we're looking for a general solution. If they give you a range of values in there, then you're not looking for a general solution. You just want to take it and say what are the first numbers that equal in that range. But this one is asking me to find those general solutions. So the first thing I want to do here is I want to isolate my trig function. And in order to isolate the trig function, I'm going to get all the numbers to the other side. And so I'm going to divide this guy by 4. So I'm left with cosine squared theta equals 3 over 4. Okay, and so now at this point, I don't know anything about cosine squared, and so I'm kind of going to do what I did a long time ago in Algebra 1 or Algebra 2, where I'm going to take the square root of both sides, so it just says cosine theta. Now remember, when you take a square root, you are always going to have, that's supposed to be an arrow, you're always going to have a positive solution and a negative solution. So when I take the square root of both sides, I'm going to end up getting that the cosine of theta, because I got rid of one of my squareds, is going to be plus or minus the square root of 3 over 4. Okay, remember when you're taking the square root of a fraction, you're really just taking the square root of the top and the bottom. So if I take the square root of 3, I don't know what that is, but I do know the square root of 4 is 2. So now this is a value that I kind of know that's on my unit circle. So I'm going to go ahead and take the inverse cosine of both sides. Remember, we don't divide by trig functions because you could lose solutions here. So I'm going to take the inverse cosine of both sides, and I have the inverse cosine of plus or minus root 3 over 2 is equal to theta. So if I can find the general solutions of this side, then I will have all the general solutions to my equation. So we can go ahead and we can draw our unit circle out with our triangles here. So first thing I'm going to deal with is I'm going to deal with the positive solutions. So I'm going to be looking at the plus root 3 over 2. So if I'm thinking about cosine, it is positive in quadrant 1 first, and so here would be my theta, and cosine is going to be adjacent over hypotenuse. So if I filled out my triangle, this would be 1, and I would know that my reference angle would be 30 degrees. And since I'm in degrees, this is easier, I just write 30 degrees. Remember, whenever I'm finding a general solution, though, I have to add in all the coterminal angles to this angle. So since I'm in degrees, a coterminal angle is going to be plus 360 degrees times n, and that's going to get me my first general solution. Now remember, on your triangle, your unit circle, there's going to be 2 places where cosine is positive. So if we thought about all students take calculus, that gets me one down here in quadrant 4, and it's going to be the same reference angle, because all my ratios would work out the same, and so I can do this one of 2 ways. I could write negative 30 degrees plus 360 n equals theta, or I could find this the coterminal, which is 330 degrees. Okay, both of those would be correct. So this is my first set of answers for this. Those are the positives. Now I have to also think about the negatives here, because remember, we had plus or minus. So when I look in here, I'm going to go ahead and think about where on my unit circle do I have a cosine value of root 3 over 2. So my first place where cosine is negative is going to be in quadrant 2. And again, this is going to be negative root 3 over 2. And then that would give me a 30-degree reference angle. However, remember, you have to find in quadrant 2 this entire angle. And so if I went from 0 all the way over here until I got a 30-degree reference angle, that would get me 150. And so there's a couple ways to do that. You could take 180 minus 30 and find that, or you can think about how many more degrees do you have to go to get to 180. Okay, and so that will get me my first negative solution of 150 degrees. And remember, we're doing coterminals here, so 360 equals theta. And then the last place on my unit circle, and boy is my little coordinate plane looking crazy right now, is over here in quadrant 3. And so again, it'll be the same ratios that we're looking at here, so I still have a 30-degree reference angle. And in order to find that reference angle all the way around, I can take 180 plus my reference angle and get 180 plus 30 is 210 degrees plus 360 n. And that is my final general solution. So when we have plus or minus, we have a ton of answers. Okay, when you do the plus or minus there, you're going to find all the places on that unit circle that have that reference angle pretty much. Okay, so again, if they give you a problem like this and they ask you for this guy, theta is all real number degrees or x is all real numbers, you're finding a general solution. And when you take a square root of a trig function, don't forget to plus or minus to the other side. Otherwise, you're going to lose two of your general solutions. Okay, let's try a different type of solving of a trig equation. Now this one looks a little bit different. We have trig functions on both sides. And so if you think about this back in the day, if we had something that looked like x minus 2 equals 5x, remember we tried to get all of the x's on both, or on one side, because that way I can like do regular inverse operations on it. So I would have subtracted the smaller number from the bigger, and I would have gotten negative 2 equals 4x, and then you move on with your life. We're going to do the same thing here. Remember, this is just a variable. Sine x is just a variable. And so what I'm going to do here is I'm going to subtract it from both sides. Because this is 1 sine x and this is 5 sine x. So I'm going to take my smaller from my bigger. So I'm going to subtract sine x from both sides. And I'm going to combine like terms. That's kind of what this is called. So I'm going to have negative 2 is equal to 5 minus 1 is 4 sine x. And now I'm going to do what I did before, and I'm going to try to get all the numbers away from my trig function. So I'm going to divide both sides by 4, and I get negative 1/2 equals sine x. Now this is just regular, what we did a while ago, and I'm going to go ahead and take the inverse sine of both sides, and then I'm going to find all of my solutions here. Now if you look at what they gave me, they just said on the interval 0 to 2 pi. So we're just looking for specific answers. However, finding the general solution is going to help immensely here, because then I can just plug in until I find all my general solutions. Okay, so since this is sine, well, that was a terrible straight line. Since this is sine, my first negative solution is going to happen over here in quadrant 4. All students take calculus using principal inverse values. And then I'm going to go ahead, and since it's sine, it'd be opposite over hypotenuse. Fill in my triangle. And I know the reference angle that would give me this would be 30 degrees or pi over 6. Okay, since it's down there in quadrant 4 though, this would be negative pi over 6 plus 2 pi n. Again, they didn't ask you for the general solution, however it's going to help us find those values on that interval. So this is the first place where I'm going to have that negative 1/2 ratio. Remember, there's two places where you have sine as negative, so I'm going to go ahead and find the other place. So all students take calculus. It's negative down here. Same ratios, which would give me, be careful, this one's negative. So since that would give me the same reference angle, again, this one is 30 degrees or pi over 6. Two ways to get there. You can go the negative angle route, or you can go and say, how did I get here? And you can go ahead and do the same thing we did before and take 180 plus that reference angle. So 180 here would be pi, or 6 pi over 6, and then add pi over 6. Okay, so that means my other angle right here would be 7 pi over 6. And again, I'm just going to go ahead and write down the general solution, so that way when I'm going and finding on the interval, it'll be a little bit easier. Okay, so that was my helpful tip right here. So since I'm looking for just on that interval, I'm going to go ahead and look and find that first one that's bigger than 0 in my general solution, so not negative pi over 6, but 7 pi over 6. And then I've got to check and make sure that where this guy is going to work. So we're going to have negative pi over 6 plus 2 pi, which is 12 pi over 6 if we found a common denominator, which would get me 11 pi over 6, which is within this interval of 0 to 2 pi. So my other answer for this would be 11 pi over 6. Okay, so that was 2 different ways that we can solve trig equations beyond what we've seen with our trig identities, and that was with square roots and with combining like terms. I will see you tomorrow.